Welcome. So this is 2.5. So at the top of your paper, you're going to write 2.5, Reasoning in Algebra and Geometry. So our objective today is to connect reasoning, algebra, and geometry. So we're connecting algebra, and now we're connecting it with geometry. All right. So here we go. First thing we're going to do is we are going to write this whole box down right here. So our properties of equality. So you're going to write down what the property is, and then on the right there, that example. So what we are doing though is we need to know these properties in order we're going to start doing proofs. So what a proof is in geometry is we have the question and we have the answer. And then what a proof is, what we're going to be doing is we're going to be explaining how did we get our answer though. So we use that through these different properties. So we're going to need to know each of these right there. So proof again is we have our question, we have the answer, and then we are proving it. We are showing each of the steps on how we got it right. So these properties we have the property of addition, which just means what you add to one side, you add to the other side. Subtraction, multiply, and dividing, same thing. If we subtract, multiply, or divide to one side, and we do it to the other side as well. The reflexive property is just that A equals A, that a number equals the same number. It's the same thing. It's reflective. It's think about like facing each other, two things. 2 equals 2, that would be something similar. The symmetric property is A equals B and then B equals A. So you're just taking those two and switching them. It's kind of like the converse that we talked about. So if A equals 4, then 4 equals A. We just switch those two. That's all the symmetric property means. The transitive property is if A equals B, B equals C, then A equals C. That's kind of like the law of syllogism that we just talked about in 2.4. And then substitution property is if A equals B, then we can place it in there. So we've done a lot of substitution property in algebra where we say if X is 5, and then we plug X right back in there. So these are all the different properties that we're going to need to know and memorize in order for our proofs. Okay? And then the last property that we're going to need to know is the property of distribution. So we're going to write this down. So remember distributing from algebra, where we use multiplication to distribute a number or a term to either the sum or the difference. So do you remember showing we're multiplying the number in front of the parentheses to each of the terms inside, whether that's addition inside or subtraction right there. Okay? So those are the different properties that we have. So we're going to use these properties in order to start our proofs. Okay? So what is a proof? Again, we talked about it a little bit. A proof is a convincing argument that uses deductive reasoning. So we've talked about inductive reasoning and we've talked about deductive reasoning. So when we're doing a proof, we are using deductive reasoning, which is facts and statements. Remember when we did inductive, that was looking at patterns. But with our proofs, we are looking at facts and statements. So a proof logically shows why a conjecture is true. And so most times when we are doing proofs, we will show it in the format of a 2-column proof, which lists each statement on the left. So we're going to make sure that we write that down. And we'll just finish off saying that the justification or the reason for each statement is one on the right. Okay, so this is what our proof is going to look like right here. We have 2 columns. We see right here we have these 2 columns, and we have our statement, and then we have our reasoning. So again, remember, a proof is you're given something, you're given the answer, and then we are proving with reasoning through deductive reasoning on why that is true. So we are first, you'll see this, we are first given this information, like angle 1 equals angle 3. And so our first statement is usually a given statement. So reason would just be given right here. After that, each of these statements are statements that should follow logical from the previous statement. So we're usually going in order, and we're using our properties in order to prove that those statements are true. And then our last statement is what we are trying to prove. So you see right here we have this is what we're trying to prove. And at the very top we see that this right here. So all of our reasoning is trying to get to our final answer of that angle AEC is equal to angle DEB. So that's what we're trying to get to though. So we have usually two columns. We have our statements and then we have our reasonings right there. And then we're trying to get to the final answer of what we're trying to prove. And that's how we show proofs. Alright, so let's do a few examples. Alright, so let's get into our first problem. We're only going to do two problems, so we're going to have problem number 1, so make sure you write number 1 right up here. And, alright, so this is what we're doing. We are justifying the steps. So we are trying to find out what is the value of x, and we are trying to justify each step. So we have dealt with the problem just like this before. So when we look at these two angles, we know that they are a linear pair, which a linear pair means that they are supplementary, and so if they're supplementary, it means that they add up to 180. So if we were to solve this problem just like what we've done, we know that these two are supplementary, and then I'll scroll back to this on the left as you guys are writing it down. We know that the two angles put together equal 180 degrees, and then we know that when we put these two angles in, and when we combine our x's, and when we subtract 30 to both sides, we get 3x equals 150, and then we divide both sides by 3, we get x equals 50. So we've done that before. So what is a proof? A proof is saying that we are going to justify each of these steps. So let's see if I can just plug this in. Boom! There we go. Alright, so let's start from the top. Okay. So make sure that you're writing this down. If you need to pause the video anytime, you can pause it. Make sure you have each of these steps down. So we said angle AOM and angle MOC are supplementary. So we say that on our right, the proof that we have is that they form a linear pair, and linear pair are supplementary. Okay. The next one is we have angle AOM and angle MOC. When we add those two together, they equal 180 degrees. And what is our property for that? We know that that is the definition of supplementary angles. Okay? So the next is we plug in, we know what both of these values are, so we plug that into both the values. What did we use? What property? The substitution property. Okay, after that, we have the, commutative property. That's just taking the parentheses away, saying we can add each three of them. The next one says the distributive property. We really didn't need to use that one. We didn't need to distribute the positive to each one of them. Then we have the subtraction property, which is saying that we are going to subtract 30 from both sides. And then our last one right here is we need to get x all by itself, so we divide both sides by 3. That would be our division property of equality, and we get our final answer of x. So we have like our two columns right there. We have each of our steps, and then we have each of the properties proving that those steps are correct, and then we have our final answer of what we're trying to prove, which we're trying to prove what x was, and in this case, x was 50. Okay? Alright, one more example. Alright, so let's get into it. Problem number 2. So we're going to write number 2 right up here. And we're going to write out this problem, and we're going to draw the picture as well. And we're going to go through our two-column proof. Okay, so it says we want to write a two-column proof. And what is given is that angle 1 is congruent with angle 3. And what we are trying to prove is the angle AEC, so let's highlight it right here, angle AEC, that angle right there is congruent with angle DEB, right there. That's what this orange one right here, let's see. So we're trying to figure out that those two angles are congruent with each other. Alright, so what do we notice first about this picture? Well, we notice that, and my highlighting skills were absolutely awful on this one, but we see that they are both share the 2 right there, right? They both share 2. Alright, so what we can do sometimes is we can use some numbers that we can put in here. We can't use it for our proofs, but if it helps us kind of think what's going on, sometimes it's helpful to add those in. So if we said that angle 1 was, let's say this was, let's say we have angle 1 right here is going to, so angle 1, let's say angle 1 was 50 degrees. So let's just write it in here. Let's say angle 1 was 50 degrees. And let's say angle 3 was 50 degrees because it said those two angles were congruent. And let's say angle 2 was 30 degrees. Well, just looking at this right there, if we take 1 and 2, add those together, that's 80 degrees. And if we take 3 and 2, add those together, those are also 80 degrees. So that would help prove that angle AEC, those two angles, AEC and DEB, are congruent because they both share angle 2 together and both angles are congruent. So even though we can use numbers to help us think what's going on, we can't use that as far as our proof. Okay, so this is how we are going to write our proof down, and there are different ways to do it, but we're always going to start with what is given. So we're going to number it off. We're going to write number 1 right here, and we're going to say what was given. It tells us at the very beginning what is given right here. It tells us that the measure of angle 1 is congruent with the measure of angle 3. And then the reason for that, we're going to put 1 right here, and that was given. So they gave us that information at the very beginning. So that is given. Alright, so we're going to step number 2 right here. Number 2. Okay, so we know that when we take angle 1 and angle 2, and when we add those together, we're going to get this angle AEC. And when we do the same thing with angle 3 and 2, we're going to get angle DEB. So we want to show that. So we're going to show that angle, the measure of angle 1 plus the measure of angle 2 is going to equal the measure angle AEC. Alright, so when we took those two angles together, it added to angle AEC. The two little ones added to the bigger one. And we can double up on this one right here, and we could say that the angle of measure 2 plus the, that's a 2, the measure of angle 3 is going to equal the measure of angle DEB. Alright, so we just showed that when we took these two angles and we put them together, we got this bigger angle right there. And so this right here is our reasoning behind this is our angle addition postulate. Addition, and we can just say postulate, get rid of it right there. So remember we talked about that when we take the two little angles and we put them together, we get the bigger angle. So when we took 2 and 3 and we got the bigger angle of DEB. Same thing with angle 1 and 2. Alright, so do we see right here how we have angle 2 and 2, how these are equal to each other right there. So we would say in step number 3 right here, that the measure of angle 2 is equal to the measure of angle 2. And this would be our reflexive property. Reflexive property. Remember that the two angles equal each other. So the two angles in a different case are both angle 2 and they both equal each other. So in our case, if they were both 30, 30 would equal 30. Okay? So now that we have this right here, what we can do though is we can substitute, since we know that these two angles equal each other, we can substitute, we know that angle 1 and 3 equal each other up here, we can substitute one of these angles in for the other one in order to get the larger portion. So we can say in our step number 4 right here, we can say that the measure of angle 3 plus the measure of angle 2 is going to equal the measure of AEC. Alright, so what did I do right there? So I had this right up here. I had the measure of 1 plus the angle of measure 2 equals AEC. But in the very beginning, we already said that angle 1 and 3 are the same. That was given to us. So if these are the same, all I did was I took the measure of angle 3 and I substituted it right where that measure of angle 1 was, because we said at the very beginning that they're the same. So I just plugged it right in. So now that I plugged it in, I said the measure of angle 3 plus the measure of angle 2 equals this measure of AEC. So how did I get that? I got that through substitution. So substitution. My substitution property. Okay? And so from there, we see that this angle 3 and the angle 2, do you see these right here? Do you see how right above angle 3 and the measure of angle 2 and the measure of angle 3, see how it equals DEB? Well, I'm just going to plug this DEB right where that is right there, because we said those two things are the same. So if they're the same, I can just plug it right in there. So my last step is step number 5 right here, which is the measure of DEB, because we said that the measure of angle 2 and 3 added together equal DEB. Well, look right here. We have the measure of angle 2 and angle 3. So we just plug that right in right where we see it. Is going to equal this measure of angle AEC. So we just plug it right in. So what was the reasoning behind that? We again use substitution. So we're going to use the substitution property. And again, now we just proved it. So that was what we were trying to prove from the very beginning. So at our last step is always going to be what we're trying to prove. So we just proved that angle AEC is congruent to angle DEB. So we use kind of our steps throughout. Yes, we can use numbers to plug in to give us an idea what's going on, but we have to use our properties in order to prove from one step to another. Okay, so I know we went through kind of quick, and there are different ways to do this problem. There's not just one way. There are different steps that you can do in order to prove it, but you have to have a statement and then a proof of property saying how you solved it, and then kind of go in order to the very end that we get what we're trying to solve, what we're trying to prove, and we have all our steps proving each of these steps are true. But there are different ways to get to it. Okay, so when we come in and we practice it tomorrow, we won't just go straight into 2-column proofs. Okay, we'll take it little baby steps at a time, because I know that some of this is confusing seeing, but we just have to be able to deduct what patterns to use as we're going through, and we will all be able to get it by tomorrow for sure. We will, one step at a time. Okay, all right, we'll see you later. Thanks for watching.